Hello and welcome everyone back to my another video. Right now you might see this render of this beautiful live trading on test data. Well, this is not live data, that's kind of curated data especially for this stuff, but mainly I'll show you what changed in this part, right? I did a lot of changes, but they are not crucial, but they really help me to work along and to continue develop on many new features that I'll be doing. So right now you might see that I'm making a buy and sell orders on this kind of sinusoid data, on this financial data, and I use reinforcement learning to do so. So basically, this is only a render that is helping me to track how my model is working, how it's performed, and so on. And right now it started again from zero. And this is my newest model, and I want to introduce you what has changed from previous part and how did improve it, and how this will help me to continue developing this kind of cool project that you can clone from my GitHub repository. So basically, this is a very similar tutorial as before. I'll follow along the changes so you could follow it together with me if you are interested to clone my repository and work on it for your own. And if you want to develop on your own algorithms for your AI trading stuff and etc. So basically, right now the results are amazing, and I'm ready, almost ready to go to the live data trading with training and testing and etc. So basically, first we need to discuss what changed and what did not, and so you would be able to compatibly use it or implement your own changes you want. So basically, it's only a render that shows me how my balance grew from 1000, and you might see the results that it grows my count value to millions, and Sharpie ratio is very huge, and of course maximum drawdown is also very large. And this is only for test data, and when we move to another part, we'll see what we can do with it with on live data and how it performs. Also, I implemented continuous environment to test how it works with the same stuff, and I want to introduce you. So don't hesitate to like this video, smash the subscribe button, comment if you have any issues, or if you have any suggestions or questions, you can always open issue on my GitHub account, and the link you can find in the description below. So let's continue on this. So right now, this render is only for, I don't know, to track how it works. For visualization stuff, it's pretty cool and it works very nicely. So, but for this video, I don't need it. That's only to view our results. So I'll close it and I'll kill it, and well, let's start moving along the code. Let's close this. So basically, as before, I want to show you what changed. And as you can see, I changed a little bit the layout. My old stuff is on the right now. This is only for recording on this tutorial because it's a little easier for you to track the code. And I'll switch it back when I'm coding, but I turned it on only for recording stuff. So let's go to my Git changes that I'm ready to push, and let's start from basic stuff. And in it, my version gonna change, and here's the data feeder that I updated slightly, but not a lot. As you might see right now, I'm able to get the name simply with a name property of this stuff. Okay, let's minimize this. We don't need this, of course. And let's follow it. What was changed? So I added the configuration. So right now we can save and load configurations of our data feeder. This is because when we are planning to test our stuff, we want to know what were our configurations, what we used when we were processing the data set, what were the data feeder, what were the minimum maximums, and etc. So to ease it up after training, I made these configurations that we save along the model, and we don't need to manually adapt this to our trained model. So that's cool. This is what changed with data feeder. Next is my, let's go to indicators. So I added one more indicator, moving average, convergent digits. And this is mainly, if you're in finance, you already should be familiar with it, but it's pretty simple. So what else changed is that I changed several parameters, but crucial changes is that I also added the configurations to each indicator. This is also to save these configurations on disk, and then later we can easily load them back with the same configurations of our indicators. For example, if we are using the moving average, we would be able to get the same moving average period. For example, we use 20 in training, so we can load the same period in testing. And if we change this in trading, we will load the same period in testing. So this way we will avoid of many errors that we might face when we want to test our models, because it should produce exactly the same results as we're in testing. So that's great. Let's go to the metrics. That's another one. Well, this also changed. I added name, so it will be easier to load them back when we are loading everything what was used in training. So nothing changed a lot here. So let's go to our rewards function. And here there was a huge change. So before I used a simple reward, and this was only as a function. And right now, as you might see, I moved this into the object because it's a little bit easier when we are creating a new custom reward functions. We need to know, it's easy to know what structure our reward object should met. So, and also this is gives us the flexibility to serialize these reward functions and load them back later, the same parameters. So in this kind of update, I added this pretty cool, we don't need this. I'll remove this later. This was my testing stuff. So I added this account value chain reward object, and this a little bit simpler reward function, as you might see, because right now here I simply calculate the account value balance change divided by the last state. So I take the new account value after our step and take the previous one and divide it by previous balance. And if it was increased, so we receive reward. If we decreased, we receive negative reward. And if it hadn't changed, we receive a 0. Well, I'm not sure if it's the best one. Maybe still I need to add, for example, trading fees into this account value change reward, but I'll test this within next tutorial. So this is basically what changed here. And let's move to another, scalars. So scalars, this is the transformer scalars. I'm not sure which one is the best yet, but I also added this kind of scalar object that defines as the structure of our object, what requirements it should met, what functions it have, and we are inheriting from this on each our scalar or transformer. And basically I here added the z-score transformer scalar, and it's different from the previous one because in this one we used a min-max scalar, and here we had to know what is our minimums and maximums values in our dataset. And this is not the best, for example, option when we are trading, for example, with Bitcoin, where our historical data is really huge. And for example, 5 years ago, our price of this asset was really low and it scales it too much. And basically, if we train our data, and for example, right now, after a year, Bitcoin will be way larger, that our training data don't have this value, then we might face some issues that our data haven't seen such huge values, and it might bring us bad results. So for this purpose, I added this z-score scalar, And what we do here is checking at the math. We can see that we calculate the difference between each candlestick price and divide this. And we receive some kind of great value that represents our price change. And to normalize this data, we proceed another calculation from returns. We subtract the mean and we divide everything by standard deviation of our data. And this seemed to work way better for me, at least, and we'll see what results it gives in our results of training and testing on the same data. Well, because before I used the minimum maximum scaler, and we'll be able to compare the result, but I'm already telling you that the results are way better. And I will believe I'll stick with this z-score scaler to continue developing this project. So next we move within the state that here haven't changed a lot, but for simplicity reasons we sometimes need to know what is the close, high, low, open, volume allocation percentage of our object instead of getting these from dictionary. And as you might see, here is my observations object that holds list of states that we are interested at the moment, for example 50 historical states. And when we are, for example, using this kind of transformer scalars or etc., we need to operate in a loop to transform each data or to get each close of this data. So in this way we'll use simply close on these observations object, and it will give us the list of our historical data in a NumPy array. This is also give us simplicity while using it. So that's it. I'm sorry for being very quick, but I don't want to spend a lot of time here because this is only a coding changes that you can view on my GitHub page. But I want to cover these two, so because few of you are interested what changed, what this brings up, what improvements this gives for us. So a lot of changes were done here in trading environment. Because in this part I introduced the continuous action space, and to make it everything tidy according to the programming rules and etc., I created these two, the discrete and continuous enumerator, to choose which we want to use. So basically all the time I was using discrete, but as I introduced this continuous, I created this one, and we might change these by action space covering. And that's it. And I also added this order fee percent that we are using right now while training our model, because without trading fees it might be too good. But as he mentioned at the beginning, I need to think this about the reward function. Maybe I need to introduce this in the reward operation. I'm not yet sure. So we'll see about that. Okay, let's move along. What else changed? So action space property. So this is a little bit easier because right now it will return us what is the action space when we are using discrete and continuous. And also I think I'll add another one when I'll introduce the short operation for environment. So that's it. And if I move along, here's the take action space. So as you may see, I'm checking whether we come with an action space that is discrete or continuous. And usually if it is continuous, we receive a NumPy array. And if it is simply actions, we receive an 1, 2, or 0 integer value to use. So basically I added this take action to it transforms our NumPy actions, I mean float actions, into standard discrete actions that are 0, 1, and 2. And it also introduces the order size that comes from the continuous action space, that it also have to be learnable. So as you might see in discrete action, where it is, yeah, in discrete action, it comes always as one order size, so we'll use it. And in a continuous order size comes from our model, and we simply round it to 2 decimals. And of course we clip it to scale it from -1 and 1 to 1, 0 and 3. So that's it. That's simple. So let's moving on. Here I also slightly modified it so that our action is 2. We introduced this order size that comes from continuous action size that could be 0.5, 0.1 or 1, that is 100%. And I introduced this in both in action of 2 and in action of 1. And of course this is simply additional value error that is raised if something wrong is out in code and we receive the allocation percentage more than 1, and this shouldn't be right. Okay, and let's move on. So as you might see, before order size was here hard-coded, and right now I moved it inside the take action. And moving on, here I also introduced these changes with configurations. Right now, when we are using our environment to train, we can save these configurations that will save our data feeder name, transformers, our metrics, and everything we are interested to have. And later, when we save these configurations, we can load them back from our configurations file and from the path. But here we need to feed this data feeder. Data feeder will be not loaded back because data feeder can be created in another place that we load configurations also. There is a specific reason for this, because when we are training our model on offline data and we are moving back to, for example, live data, live trading, we are using data feeder that it will be different, that will pull data from online source, and here we'll use another data feeder and we can't load it back. We need to create a new one for specific for this reason. So that's mainly it. So I covered trading environment, state, scalar, reward, metrics, indicators, and data feeder. So I of course updated the changelog. I tried to summarize everything here, what I explained right now, and give you in short what I did. I updated the requirements, RockRL version upgrade, because I fixed one bug fixed there that was here. So basically I improved the performance of this reinforced learning stuff by simply moved logging into threading, and right now it doesn't take any time, because usually when we are trading we might want to use logs to, for example, to TensorBoard in many places, and usually this takes around 10 milliseconds to log stuff, and if in one loop we have, for example, 10 logs, it will consume us 100 milliseconds. This is a 10th part of the second, and if we talk about training it for 1 day or week, that's pretty a lot of time. So I decided to give this improvement there. So great. And right now I did some minor changes here, but this is only for testing stuff. As you can see, I use this mainly for testing while developing how it works with a random data, and I updated this with a metrics, new indicator, account value change reward, z-score scalar, and etc. And here I save these configurations. But let's move to our training discrete code. This is a new one because before I was doing everything here, and I simply updated this code and moved this to more specific with training PPO sinusoid on discrete. And let's walk through it pretty quickly. And what I'm doing here, mainly I'm importing a lot of stuff from FinRock. This is indicators, metrics, rewards, scalars, trading environment, and etc. Before I used simple reward. Right now I use account value reward. And I improve a lot of stuff from RockRL reinforced learning library. This mean average, memory manager, PPO, agent, and vectorized environment. So before it was taking a lot of time to train our environment because we were able to train only one environment at a time. So this time I put this into a vectorized environment, and it is a little faster. So the same way as before, I create a data feeder. I create a vectorized environment, and if before I was creating this trading environment as simple as here, like this. Right now, instead of creating environment like this, I am moving it into vectorized environment object, and I give the object what environment I need to vectorize, and I give all arguments the same arguments that I was giving into my trading environment. As simple as that. And then at the end, I receive these action spaces, observation spaces. I move these models into functions, so it's a little bit simpler. They are still very basic, and I'm not very sure if this will work within real data, but with sinusoid data, it works for me for developing stuff. So for now, I still use them. And let's move with a PO agent. Nothing changes here. And I simply save the configurations of my pandas data feeder and of my environment. Because my main environment is vectorized, it doesn't have such save configurations, so I use environment of environment and save configurations. And here I use a memory manager. Before I used manager to create this memory, and right now simply I create these according to the number of environments I'm using. And here is my mean average and etc. And now that is very similar loop as before. I simply send the states to my agent. I collect these results as states, actions, rewards, probabilities, terminated, truncated, next states, and info dictionaries into my memory. And here I check here I check whether which environment has achieved this done state. That means the done state is when terminated or truncated appears, and usually this happens when we achieve maximum environment steps, and usually it is max episode steps usually. Otherwise you can set something different, for example when your balance drops between 50% or etc., and it will reset it and will not continue to train it. And then when we achieve this, we collect the environment memory by index of our environment which achieved this state, and then we collect this history by training on this memory. We calculate the mean average by checking what is the memory reward, and then we have the mean average. If it's best, I save the model, and then I use additional KL divergence metric to track to reduce the learning rate of our models. I already talked this before in my previous parts, I'm not replicating myself. And then I'm collecting the info dictionaries that I log into agent into my TensorBoard. And then I simply reset the environment of the same index and reset the states and infos. And if my agent achieves 10,000 episodes, I simply break it and I close the environment and leave. This means my training loop has finished. I'm not really sure yet if it's the best way I'm doing this, but that's how I'm doing. So if I go to same testing code of this environment, it's changed a lot because of these configurations, as I said. Because if I'll move to my runs, for example, this one. So there you might see there is a lot of pandas data frame JSON, trading environment JSON, and config JSON. And basically this is all the configurations. This config might be empty yet, but yeah, this is empty, but this is not the idea. Idea is that right now it changed a lot, and right now I need to load only these configurations, pandas data frame from configurations. I feed this new data frame that I will use for testing, this data for testing. Then I use the same for my trading environment. I load the same pandas data feeder into it and modal path. This means my modal path, where is my configurations. I receive these action space as input and so on. And then I'm able to test this out. Well, because my agent predicts the discrete action space, I simply use argmax. And if I go to my continuous, this is very similar. Everything is the same, except that my actor model is a little bit different because I need to get the output action and sigma combined. And sigma is my randomness that my model learns, and action is my action space in floats. And yeah, that's it. And here I also do the action a little bit differently, but this is handled inside the agent. And if I go to testing PPO sinusoid continuous, everything is the same except this one that I predict on a state. Oh no, it's also handled by the environment, this continuous action space. So I simply remove this randomness from the model that it needs to predict, and I use simply action from the model, and that's it. And probably you might be interested to see what are results in a training loop. If I open my TensorBoard, first let's open my previous training loop. Okay, reboot this. It was trained for 10,000 steps. And what I'm interested is Sharpe ratio and rewards, of course. And I'll remove this moving, and let's look at this. So maximum drawdown also I'm interested. So what there was before, you might see while it was training, it was giving me a lot of maximum drawdowns, but that were really huge. This means that my trainable agent is not stable. Even more, it achieved very huge rewards, and Sharpe ratio was around 25 in average. Let's look at the other sigma, for example. So this means the randomness. It started here, it jumped and started decreasing. This means it was learning with 0.1% of randomness and then even decreased. And what is our account value? Let's open the log. And it's not very stable, but these values, as you might see, it's very huge. So let's look at my new agent where I made some improvements. And what I'm really interested is, again, this sigma that I added. This is with a new reward function and moving average converged dimensions indicator. So this is very good. As you might see, sigma is way more stable, and later it gave less randomness. Sharpe ratio is even larger. This means that it's way better than the blue one, and it was way more stable. What is the maximum drawdown? As you might see, it's way more stable than before. It is keeping around 0.1 an average, and while before it was huge drawdowns. And let's look at the different actions. It's a little the same, but it's very high, a lot of actions actually, because I train on 1000 episodes. This means that every second candle it does some kind of action, and rewards also are way larger. Well, we might see, I don't know if we need to focus on this right now. One big disadvantage is that this might be bad because I'm training on sinusoid data. My very simple model might be overfitting it, and I can't see the real results. But at least I know that my new reward function works slightly better than before because my model trains in more stable way. So let's look at my continuous environment that I also trained for 20,000 steps. And you might see that it doesn't perform as well as my discrete because it might be too hard for my continuous environment to learn this stuff. This might be before or the reason because my agent is very simple, only with the dense layers, and it's really hard to learn this kind of sequential data. But still it tried, and this kind of decreased. Everything looks pretty amazing. Sharpe ratio was around 10. It's not that good as 35, that is insane, but it's still 10 is very good. And what are my rewards? There were 5. By the way, I need to mention that blue and red, why there's so huge difference, because we are simply using different reward function. And that's it. Maximum drawdown, as you might see, it was also not that stable as my red discrete model. And that's it. What my account value, it wasn't able to achieve that huge values as my discrete one, but still it was learning. So this means that it's not the end. The continuous is not bad, but still I need to continue investigating on it and training, trying new stuff, another model, and etc. So that's it, what I wanted to show you, what introduce you in this part, and I'll continue to work on this. So my goal for next tutorial is maybe to add new features that I need to fix, but main priority is to introduce a short option for the prices, and maybe I'll start to thinking about live data. So we'll see you there. So that's it for this tutorial, and we'll see you in the next part. Don't hesitate to smash the like button, subscribe, comment if you have anything to tell me, or you have any questions, suggestions, or etc. And always there is my GitHub page where you can open an issue, so I definitely gonna see your message. So thank you for watching, and see you next time. Thank you.